The human ankle is pretty amazing. Not only does it support the entire weight of the body, it's also incredibly complex and capable of a wide range of movements. So we're going to break this down piece by piece. We'll look at every bone in the foot, all of the joints of the foot and the ankle, and then we'll focus in on the ankle joint or the talocrural joint specifically. We'll look at the main ligaments that give structure to that joint, as well as the primary muscles that cause the different movements of the ankle. Throughout the video, we'll look at real human cadavers and other cadaveric images provided by Anatomage, the maker of the world's first life-size virtual dissection table. So you can see how all of these structures are arranged three-dimensionally in the body. And at the end of the video, I'll have some blank diagrams for you to practice, because when it comes to learning the ankle joint, I want to make sure you get off on the right foot. So let's jump to the whiteboard and get started. Let's start with the bones of the foot and the ankle, and we've got two different views here. We have a frontal view and a lateral view, and of course we're not going to start with all the bones on there at once, so let's get rid of those and do those one at a time. The first bone we're going to look at is the tibia, and the tibia is going to be the main bone giving structure to the lower leg, and of course we have the second bone there, the fibula. So the tibia and fibula are the bones of the lower leg, and those are going to articulate directly with the tarsal bones. Now there's 7 tarsal bones, and we've got a mnemonic for helping us remember those, and that mnemonic is tiger cubs need milk. So as we go through these tarsal bones, keep in mind that mnemonic and use that as a way to remember these as we go through them. So the first one that's going to articulate directly with the tibia and the fibula is the talus bone. I always immediately think of the stone talus monsters from the Legend of Zelda games, and this looks just like the stone talus. I think they just took this and copied straight from it probably. And this connection between the tibia and the talus bone is going to form the tibio-talar joint, also known as the talocrural joint, or as we often call it, just the ankle joint. We'll talk more about that a little bit later in the video. Next, we have the calcaneus. The calcaneus is your heel bone. It's going to articulate directly with the talus right here, forming the subtalar joint, which we'll learn more about later on too. So tiger cubs, talus, calcaneus. Remember, the talus is going to articulate directly with the tibia, and the calcaneus is your heel joint, which articulates with the talus. Now, in addition to the tiger cubs need milk mnemonic for remembering this, I tend to think of the bones of the foot in two kind of sections. We're going to have one section that corresponds with the talus. That's going to be the bones that kind of come off of the talus in the front here. And then the calcaneus separately, and it's going to have some bones that kind of come off of the calcaneus on this side right here. That's one way that I categorize these into two different sections to help me remember them. So I'll kind of go over that and go in that order as well. So the talus is going to articulate with the navicular bone. Navicular, I think of navigate, and when you navigate, you usually have multiple directions that you're deciding between. And this navicular bone is going to navigate between 3 different cuneiform bones. So we'll take a look at these 3 cuneiform bones next that the navicular bone is navigating between. And again, I'm just using that navigation metaphor as a way to help it become a little bit more sticky in my brain, help me encode that so I can remember it a little bit better. Now, if we have 3 cuneiform bones, we have to have ways to distinguish between the 3. And so we're going to use the directional terms lateral, intermediate, and medial. This is the medial side. This is the lateral side. So medial, intermediate, lateral, and of course those are going to form the first 3 letters of milk: medial, intermediate, and lateral. I'll draw those over here on my lateral view as well. And so here is the lateral cuneiform bone, the intermediate cuneiform bone, and the medial cuneiform bone. So when I was learning this, I thought of the talus, navicular, cuneiform bones as kind of one group of bones that are going to articulate with the first, second, and third metatarsals, and then the first, second, and third sets of phalanges in the foot. And then separately, I've got the calcaneus and this next bone right here, which is the cuboid bone. Now, when they name this, I feel like they got it wrong because it's not really shaped like a cube in my mind. Like, that's not that. I mean, you got to really use your imagination to call that a cube, but we call it the cuboid bone because somebody thought it was cube-shaped. That cuboid bone articulates with the calcaneus right here and articulates with the lateral cuneiform bone as well. And that cuboid bone is going to articulate with 2 different metatarsal bones, our metatarsals 4 and 5. Now take these bones all together and you're going to have the tiger cubs need milk. Before we go on, let's connect that back to our mnemonic. Tiger cubs need milk. Tiger is the talus. Cubs is calcaneus. Need for navicular. And then milk because we've got the medial, intermediate, and lateral cuneiform bones. And then cuboid. So MILC for milk. Now just distal to the tarsal bones, we're going to have the metatarsals. So let's take a look at the metatarsals next. We're going to have 5 metatarsal bones. We're going to number them 1, 2, 3, 4, and 5. So let's add in those numbers right here. The big toe is going to correspond with metatarsal 1, and then all the way to the pinky toe is going to correspond with metatarsal 5. Now your metatarsals are not your toe bones, but they line up with your 5 toes. Now metatarsal number 1 is going to be called the hallux, and so that metatarsal along with the phalanges there is going to form the hallux. If you remember from the hand, the thumb was the pollex, so similar we have a name for this first big toe, which is the hallux. Just distal to the metatarsals are going to be the phalanges of the foot. So the phalanges, we're going to have 3, except for on the hallux, we're just going to have 2 phalanges. And if we have multiple of those bones, we have to have a different way to distinguish each of those. So we're going to have first the proximal phalanges. And so this would be proximal phalanx number 1, proximal phalanx number 2, 3, 4, and 5. Next, we'll have the middle phalanges. And notice we don't have a middle phalanx on the hallux because the hallux is just going to have 2 bones that we'll call proximal and distal. So we'll have middle phalanges on digits 2, 3, 4, and 5. Finally, we have the distal phalanges, and we'll have the distal phalanges on each of the digits. So your hallux or big toe is going to have 1 fewer bone than all of the other toes. So we've got the tarsals and metatarsals, the bones of the foot, and then we've got the phalanges, which are the bones of the toes. And here in our cadaveric images from anatomage, we have the talus bone, the navicular bone. Here's the medial, intermediate, and lateral cuneiform bones. Here are the first 3 metatarsals, and then the first 3 sets of phalanges. And here we can see the calcaneus bone, the cuboid bone, the 4th and 5th metatarsals, and the 4th and 5th sets of phalanges. So those are all the bones of the foot and the ankle. Now is probably a good time, if you're learning this for the first time, to pause the video and see if you can name all of those different bones of the foot and the ankle. Practicing that will help you encode the information a little bit better. Strategies such as using a mnemonic, like tiger cubs need milk, or practicing labeling and identifying structures like this, or using things like 3D models, like the ones from anatomage in this video. Those are all things that help you encode the information to make it stickier in your brain so you can learn it better. In fact, if you're learning anatomy and physiology and want to use the best study strategies, check out my free A&P survival guide, link in the description for that. All right, let's move on to the joints of the foot and the ankle next. The first joint we're going to look at is the tibio-talar joint, or the talocrural joint. Now with most of these joints, we're just naming them based on the 2 bones or types of bones that are forming that joint. So tibio-talar, tibio referring to the tibia, talar referring to the talus. We also have this term talocrural, talo for talus, and then crural just means the leg. So this is where the talus is articulating with the rest of the leg. When we talk about the ankle joint, this is the main joint that we're talking about. This is going to be a hinge joint, and if you know that hinge joints only have 1 degree of movement, and so this is going to be where we have dorsiflexion and plantar flexion. Dorsiflexion is where the front of the foot moves up like this, and plantar flexion is where the foot moves down like this. The next joint is the tarso-metatarsal joint, and so that's going to be connecting the tarsal bones with the metatarsal bones right here. Those are going to be plane joints. Plane joints are joints that have smooth, flat surfaces that can glide across each other. And the tarso-metatarsal joint isn't going to allow for a lot of movement, but it is a synovial joint. It is a plane joint. Next, we have the metatarsophalangeal joints, and that's going to be between the metatarsals and the phalanges. And this is going to be a condyloid joint. Condyloid joints are where one side has a rounded surface, kind of a circular-ish surface, and the other bone will have a concave surface, and those will fit together to allow a lot of degrees of freedom of movement. And think about if you're moving your toes, just like moving your fingers, you can kind of move those in a lot of different directions, like side to side, up and down. That condyloid joint allows for that free movement of the toes. And finally, we're going to have the interphalangeal joints. So we'll have proximal interphalangeal joints and distal interphalangeal joints. And of course, on the hallux, we just have 1 interphalangeal joint. The interphalangeal joints are hinge joints, allowing for just 1 degree of movement. And so think about moving your toe, just like moving your finger. You can't really move this joint right here or the joints in your toes side to side. You really only have this 1 degree of movement of those joints because they are hinge joints. And one other really important joint that we have here is going to be the subtalar joint. That's going to be the joint between the talus and the calcaneus. That's going to be another plane joint, so 2 kind of flat-ish surfaces that slide along each other. And that's going to be the main joint that's moving whenever we do inversion and eversion of the foot. And so inversion is where we're taking the foot and kind of bending it towards the inside or bending it medially. And eversion is when we're taking the foot and bending it the opposite way toward the lateral or side of the body. Later on in the video, when we do the muscles, we're going to be really looking at the tibio-talar joint and that movement of plantar flexion and dorsiflexion, and then the subtalar joint of inversion and eversion movements. And I didn't get into all of the intertarsal joints, but all of these articulate with each other. So we've got lots of little joints kind of in between the tarsal bones as well, but I didn't label those on the diagram. Up next, let's take a look at some of the ligaments of the ankle joint, specifically the ligaments of the talocrural joint. So let's start with the lateral view here. First, let's look at a group of ligaments that are collectively called the lateral collateral ligament of the ankle. These are all going to be working to stabilize the talocrural joint, and so that's going to be like the tibia, the fibula, and the talus, stabilizing that complex right there. The first is the anterior talofibular ligament. And just like the joints, the ligaments, we're just naming them after the bones involved. And so this is going to be the talofibular because it's connecting the talus to the fibula. It's the anterior one because it's on the anterior side, and that implies the existence of a posterior one. So next we have the posterior talofibular ligament. The anterior is going to prevent the talus from moving anteriorly, and the posterior talofibular ligament will prevent the talus from moving posteriorly. And the third one then is the calcaneofibular ligament, and that's going to connect the fibula to the calcaneus. Note when you're naming these, you always have fibula on the end, which is going to be opposite we'll see of the tibia, where you have tibia at the beginning of the word. So the lateral collateral ligament is made of the anterior and posterior talofibular ligaments, as well as the calcaneofibular ligament. Now let's take a look at the medial side. The medial side is going to have its own collateral ligament, a group of ligaments that we'll call the medial collateral ligament, or also the deltoid ligament. Those are both names for these four ligaments that combine to stabilize this joint. The first three kind of mirror the lateral collateral ligament. First, we're going to have the anterior tibiotalar ligament that's going to connect the talus to the tibia. Of course, then we must have the posterior tibiotalar ligament connecting the talus to the tibia on the posterior side. And just like the lateral collateral ligament, we're going to have one between the tibia and the calcaneus. So we'll call that the tibiocalcaneal ligament. Now, unlike the lateral side, we've got one additional ligament that we're going to add to the medial collateral ligament. And that's going to be the tibionavicular ligament, which is going to connect the navicular bone right here to the tibia. So stabilizing the talocrural joint on the medial side, we've got that medial collateral ligament, also known as the deltoid ligament, and it's made of the anterior and posterior tibiotalar ligaments, the tibiocalcaneal ligament, and then the tibionavicular ligament. I have two more ligaments I want to include on here, and these are going to help stabilize the tibia and the fibula together. So of course, those are going to be called the tibiofibular ligaments. So we have an anterior tibiofibular ligament, as well as a posterior tibiofibular ligament. So here in our cadaveric images from Anatomage, we can see the posterior and anterior talofibular ligaments, as well as the calcaneofibular ligament, and those make up the lateral collateral ligament. On our medial side, we can see the anterior and posterior tibiotalar ligaments, the tibiocalcaneal ligament, and the tibionavicular ligament, that all make up the medial collateral ligament, or the deltoid ligament. And here we can see the two ligaments stabilizing the tibia and fibula, which are the anterior tibiofibular ligament and the posterior tibiofibular ligament. Also, those of you watching at home, I had so many outtakes trying to say things like tibiofibular and talofibular. So if you have trouble pronouncing these, so do I. We've got an anterior tibiofibular, and we have an anterior tibiofibular. I'll try that again. So those are the ligaments of the talocrural joint. Now let's look at the muscles of the ankle joint. And before we go into those muscles, let's review those four movements. First, we have plantar flexion, and that's going to be when the front of the foot points down like this towards the plantar or the inferior part of the foot. And then we have dorsiflexion, where the foot is going to move up towards the dorsal surface of the foot like this. Those will be movements of the tibiotalar joint. The other two movements that we want to make sure that we know are going to be inversion and eversion. So in inversion, we're going to be rotating the foot towards the medial side like this, and that the primary joint there moving is the subtalar joint. And then we have eversion, where we're rotating the foot towards the lateral side of the body. So all of the muscles we're about to go over are going to correspond with one of those four movements, and that's how I'm going to categorize them in the video, and hopefully that'll help you remember these muscles better as well by categorizing them based on movements. Categorization is one of my favorite encoding strategies when I'm learning new information like this. So let's start on the medial side of the foot, and the first muscle we're going to learn is the gastrocnemius. The gastrocnemius is actually named after stomach because somebody saw the main body of the muscle and said that it looked like a stomach, so they called it gastro. Most of the muscle is kind of up off of the diagram here. And the gastrocnemius is connected to the calcaneus via the calcaneal tendon. Calcaneal tendon is also known as the Achilles tendon. So if you're familiar with the mythology story of Achilles, where his mother held him by the ankle and dipped him into the water that protected his body, the one place that didn't get protected was the calcaneal tendon or the Achilles tendon, because that's where she was holding him. The gastrocnemius is going to be involved in plantar flexion. It does plantar flexion by pulling up on the calcaneus. If it pulls up on the calcaneus, that's going to rotate the rest or the front of the foot downward in the plantar direction or the inferior direction. So it pulls up on the calcaneus, making the rest of the foot point downward. Another muscle involved in plantar flexion is the soleus muscle. This one is also connected via the calcaneal tendon to the calcaneus. So gastrocnemius, soleus, both connected via the calcaneal tendon and causing plantar flexion. And the third muscle we'll look at here is the plantaris muscle. In the diagram, all you can see of the plantaris muscle is the tendon itself, because the actual body of the plantaris muscle is really, really high up, really superior on the leg. All three of these muscles have their insertion on the calcaneus. The gastrocnemius and the plantaris actually have an origin all the way up on the femur, the distal end of the femur, whereas the soleus has its origin on the proximal end of the tibia. And all three will contract to pull the calcaneus up, causing plantar flexion. So those are the primary plantar flexor muscles. Here's a list of some other muscles that help with plantar flexion as well, but the three that we've gone over, they're the main ones causing most of the force of the plantar flexion movement. Now the opposite of plantar flexion is dorsiflexion, and this next muscle, the tibialis anterior, is going to be the primary dorsiflexor of the foot. The tibialis anterior is on the anterior side of the tibia, and it actually has an origin on the lateral surface of the tibia, on the proximal end of the tibia. And that muscle and tendon are going to extend all the way down to right here, where it has an insertion on the first metatarsal, as well as the medial cuneiform bone. And when that tibialis anterior contracts, it's going to pull the front part of the foot upward, causing dorsiflexion. Here are some other support muscles that help with dorsiflexion, but the tibialis anterior is going to be the primary dorsiflexor of the foot. The next movement we're going to look at is inversion, and for inversion of the ankle, it's going to involve the tibialis anterior as well as the tibialis posterior muscle. Now for inversion and eversion, one way to remember what muscles do those two movements is really easy. You just remember that the tibialis muscles, the two muscles with tibialis in the name, anterior and posterior, those are involved in inversion. And then in a minute, we'll see that the muscles that have fibularis in the name, those are involved in eversion because they're going to be on the lateral side. Now the tibialis posterior is going to have an origin on the tibia. That's going to be the part of the tibia that's more superior or proximal, and it's going to be on the posterior surface of that tibia. And its insertion down here is going to be on a lot of different bones actually. It's going to be on the navicular bone, the cuneiform bones, all three of them, as well as some of the metatarsal bones. So this tendon right here, it kind of splays out and connects to a lot of different bones on the inferior part of the foot. And when those tibialis muscles contract at the same time, they're going to both be pulling on this medial side of the foot, causing inversion of the foot. So quick recap of all these muscles on the medial side. The gastrocnemius, soleus, and plantaris muscles will do plantar flexion. The tibialis anterior will do dorsiflexion. And the tibialis anterior and posterior together will cause inversion. Now let's jump over to the lateral view of our foot and look at the fibularis muscle. These three muscles are going to be involved in eversion of the foot. And the first one is going to be the fibularis brevis muscle. The fibularis brevis will have its origin on the fibula, and then its insertion is going to be on the fifth metatarsal right here. If we have a brevis muscle, meaning short, we must have a longus muscle, meaning long. So we've got the fibularis longus muscle right here. It will also have an origin on the fibula, and then its insertion will be down here. And we've got a third fibularis muscle, and so they just decided to name it the third fibularis muscle, and they called it fibularis tertius, meaning the third. Its origin, of course, is on the fibula, and its insertion is down here on the fifth metatarsal. Now you can imagine if all three of these muscles are contracting, they're going to be pulling up on this lateral surface of the foot, causing that eversion motion that we've been talking about. So remember the tibialis muscles causing inversion and the fibularis muscles causing eversion. And here in our cadaveric images from anatomage, we can see those muscles that we've been talking about. Here we have the gastrocnemius, soleus, and plantaris muscles. Here we have the tibialis anterior and then the tibialis posterior. And here on the lateral side, we have the fibularis longus and the fibularis brevis muscles. The only way to make sure that you know that really well is to practice retrieval. So I'm gonna give you a few blank diagrams. Take a moment, pause the video, see if you can name all of the bones of the foot and the ankle. And then here are the answers to those. Up next, see if you can name all of the joints of the foot and the ankle. And there are all the joints. Now pause the video, see if you can name all the ligaments that are stabilizing the ankle joint. And here are all of those ligaments. All right, next we have the muscles. Pause the video, see if you can name all the muscles on the medial side of the ankle and see if you can name all the motions that they do. Here are those muscles. And finally, let's take a look at the muscles on the lateral side. Pause the video, see if you can name those 3 muscles as well as the function that they do. And here are those muscles. Hopefully you learned a lot about the ankle. Special thanks to Anatomage. Check out their link in the description below. My favorite thing about Anatomage is that they use actual scans of human cadavers. So when you're looking at the anatomy in Anatomage, you're not just looking at an ideal image of it, you're looking at what it actually looked like in somebody's body. They've got multiple cadavers so you can compare diseases and all that kind of stuff. So check that out in the link in the description below if you want to know more about them. Special thanks to my patrons on Patreon. Thank you all so much for supporting the channel. If you're interested in joining the Siebert Science Patreon, I have blank diagrams from all of my videos available on the Patreon to all tiers of subscribers. And like I said before, if you want to make sure you're using all the best strategies to learn A&P, check out my free A&P survival guide. And if you want to learn more about the joints in the body, check out this playlist of videos to learn more about those. Thank you so much for watching, and I'll see you in the next video. All right, bye-bye.